Today, I'm going to tell you about one of the biggest mysteries of the microcosm, the Higgs boson. By 1960s, the scientists already have learned a lot about microcosm. Masses and velocities of most of the elementary particles were measured. The standard model of atom describing particle interactions started taking shape. Though it was still unclear why every fundamental particle's mass is exactly as big as it is, and are the masses connected with the velocities in some way. And finally, in 1964, the British theoretical physicist Peter Higgs proposed a new theory. We are all familiar with the idea of a field. Gravitational, magnetic. But in his theory, Higgs proposed a field of another type. The main difference of Higgs field from others is that it goes through the whole space and its effects are evenly distributed in all directions. Guided by this theory, we think that all fundamental particles gain mass from interaction with this field. To illustrate this theory, I will use a popular analogy with the snow field. If you are a skier or a snowboarder sliding across the top of the snowfield, you can go very fast. You are like a photon, which doesn't interact with Higgs field, its mass equals to 0, and it travels with the speed of light. But if you are wearing the snowshoes, you will be sinking into the snow a little, and you won't go as fast as a skier. You are like an electron, which weakly interacts with the Higgs field. It has a small mass, and its speed is less than the speed of light. And finally, if you put on valenki, then you will sink deeply into the snow, and you will have to go slow like heavy particles, for example neutrons. Thereby, the more a particle interacts with the Higgs field, the heavier the particle is, and the lower is its speed. In this analogy, we can associate the smallest particle of the snow field, the snowflake, with the smallest particle of the Higgs field, the Higgs boson. In 2012, in Switzerland, on the Large Hadron Collider, by detectors ATLAS and CMS, the boson was experimentally recorded. Discovery of the Higgs boson has opened a whole new direction of the research in elementary particle physics. In the closest future, it can change our understanding of the standard model of atom and of the universe in general.